Hello everyone, welcome back to the channel. In this video, we'll be discussing about the third problem of today's weekly contest, minimum cost to make array equal. The problem states that you are given two array nums and cost. You have to perform the following operation any number of times. What is the operation? Operation is you can increase or decrease any elements of nums by one. Okay, and whenever you do this, like whenever you perform one operation, you will be paying cost of I, where I is the index of the element which you are modifying, which you are either increasing or decreasing. Now you can, like, the final goal is to make every element of nums equal. So you can decrease or increase any elements here, right? So you can actually make everything here equal. Now, there are various possible ways to make everything equal here. Among all such possible ways, you have to return the one which have minimum total cost. Okay, so let's take an example. This is the array, this is the cost. So what does this cost indicate? Let's say from 3, you can go to either 4 or 2, increment or decrement. And if you go like either you go to 4 or 2, you will be paying 3 unit of cost. Okay, so what they are saying is like the target is to make everything equal. So what they are saying, you can make everything to 2, and if you do that, you will be paying 8 unit of cost, and that is the minimum possible cost that you can pay. There is no other element with which you can make everything equal and still pay lower cost. Okay, so hope the problem statement is clear. Now let's look at the solution. Now, again, we will be building the solution step by step as I approached it during the live contest. So we have these two uh, constraint. We can increase element and pay cost I. We can decrease element and pay cost I. Okay. Now, what we know that we can make, like, we can find out easily, very easily, what is the cost of making everything equal to x. So let's say x is 3. You are making everything to 3. So what is the cost of making this 1 to 3? You have to make this one 3. So you have to increment it twice. So if you are incrementing it twice, you will be paying 4 unit of cost. Now, what is the cost of making this 3 3? This is already 3, so you will not pay any cost. For 5 to 3, you have to decrement this twice. So you will be paying 2 unit of cost, right? Now, similarly, for from 2 to 3, you will be incrementing it once, so you will be paying 14 unit of cost. So finally, you will be paying 4 plus 2 plus 14, which is 20 unit of cost to move everything to 3. Okay. Now we know what is the value, like what is the value of a single element, of bringing a single element to all equal element x, and we can find out that very easily in order and time, right? We can just iterate and just calculate the values. Now, what are the possible values of x? So notice that nums of I, which is the initial value of every element, is between 1 and 10 to the power 6. Okay. Now, can we make everything here less than 1? Let's say, can we put x equals to 0, or rather, in a different way, can x equals to 0 is a valid candidate? The answer is no. Why? Because of this constraint. I will encourage you to pause the video and think about it for a moment, and play back again to get the answer. So we have, like, let's say you get C cost to move everything to 1. Okay, you are paying C cost to move everything to 1. Now, to move everything to 0, you will be paying greater than C cost always. Why always? Because to move everything to 1, you have already paid C unit of cost, right? So everything here is 1, and you have paid C unit of cost. Now you have to move everything to 0. So this will be decremented once, this will be decremented once, this will be decremented once, and this will be decremented once. So everything here, like, you will be paying one unit of cost for every element here. So basically you are paying some C plus some unit of cost, right? So every time you move from 1 to 0, you will be paying greater cost than you have paid at 1. So why you will move to 0? Because you can always stop at 1 and just say that, okay, I will pay C unit of cost and I will skip going to 0, right? So this is possible because cost of I is greater than equals to 0. If any of this cost is less than 0, we can't say this because let's say this is minus 14. So moving to 0 might actually benefit us, right? So that's where we can't move to 0 in the current situation. Okay. So now the similar argument can be made for C greater than 10 to the power of 6. Uh, Sorry, for making everything greater than 10 to the power of 6. So you will not want to make anything here greater than 10 to the power 6 because 10 to the power 6 is the maximum element in our array. Now, if you make everything greater than 10 to the power 6, let's say 10 to the power 6 plus 1, you will be paying more cost than 10 to the power 6 because everything here you have paid already, let's say C cost, and by same argument you will be paying greater than C cost because you have to move everything by one element forward and you will be paying all this cost. So the cost would be greater than equals to C if it is greater than equals to 0. Okay, so basically you can stop at 10 to the power 6. Okay, now we know what are the possible candidates of x. Okay, so possible candidates of x is within 1 to 10 raised 6, right? So these are the possible candidates of x. And for each x, we know we can calculate the actual cost in order and time. So what is the brute way now? The brute way is to just find out the value or find out the cost for every possible x. So how many possible x are there? 10 to the power 6. So 10 to the power 6 into n. This would be the time complexity if we do it naively. But surely this will not pass because n is up to 10 to the power 5. So this will surely not pass. Now we have to remove something. Either we can remove this or we can remove this or we can change our approach altogether. So we can't remove n. We have to iterate over everything at least once to get some insights, right? So we can't remove n. So we have to remove 10 to the power 6 somehow, or we can remove n if we are able to find a way where we can find out the cost in less than order and time, maybe by doing some kind of pre-computation. Okay, so the like if you think of it, removing 10 to the power 6 is a lot more difficult than removing n. Because if you remove 10 to the power 6, what you are saying is you will be not like first. Okay, let's take a step back. So we have to remove one of these. Now we are doing a linear search over x. So in most of the questions, it might be the case that you can, instead of doing a linear search, you can do binary search. So let's look at if binary search is applicable here or not. So just to remind, what is binary search? Binary search is if at any point x, if you are able to decide whether to skip the left half or the right half, like you will not go into the both half by some with some condition, you can able to determine that I will not go in the left half at all, and I am sure my answer exists in the right half. Similarly, you can decide I can't go right half and I am sure that my answer exists in the left half. If you are able to do so, then you can apply binary search. Let's look at what happens here. Let's say this is the cost and value graph. So this is x and this is the final cost. Okay, so let's say at x equals to 1, cost is maximum. Okay, now while and let's say the cost is maximum at x equals to some maybe 100. Okay, now these 2 point cost are maximum. Now what happens in between? In between, cost will decrement, right? And after decrementing, it will again start incrementing and will reach 100. Okay, So we have to find this point, right? Now, the thing is, you can't, like, you can find this point by using binary search or ternary search if this is a strictly decreasing slope. But the thing here is, for 2x, like, what is strictly decreasing? Strictly decreasing simply means that for any two value of x, the cost will not be same. Okay, but here that is not the case. It can happen that for, let's say, x equals to 3 and x equals to 5, the value of x is exactly same. So the graph will not look something like this. Instead, the graph would look something like, it will come down and then it will stay the same value, and then come down, stay the same value, and then come down and stay the same value, and so on and so forth. So basically, you don't have a single point here. So applying binary search here is not possible. So if you don't understand this, don't worry. This is a standard problem. If you want me to explain this part in a separate video, do let me in the comment section below. If there are more than 100 people showing interest, I will definitely make a video today itself. Okay. So now moving forward, we can't apply binary search. So basically, we have to iterate over all such possible sample spaces. Okay, so now what is the choice? The only choice that remains with us is, we have to remove this n somehow. So what removing this n means, for each of these possible combinations, we have to find out the cost by not iterating over every element by some other way. Okay, so hope the now the new problem statement is clear. Basically, what we are saying, we will iterate over everything from 0 to 10 to the power 6 or 1 to 10 to the power 6, and for each of these we want the value, or we want the cost, and we want the cost in less than order n time. Okay, now let's say you already know the cost for making everything to some x. Okay, or let's take an example. Let's say you know everything, you know the cost of making everything 4, or let's say you know the cost for making everything 3. But we have calculated just now that it is 20. Okay, so 20 is the cost and 3 is the value. So you know everything, to make everything 20, to make everything 3, you will be paying 20 unit of cost. Now, from this 20 unit of cost, can you determine somehow that what is the cost of moving everything to 4? So let's see. You make everything here 3, right? So everything here is now 3, and you have paid 20 unit of cost. Now you have to make everything 4. So what will change? There are some element which are less than 3, and there are some elements which are greater than 3. Now if you are making everything 4, what happens? Everything here, right, have to pay 1 unit of cost, because they will be moving one step forward. So previously, everything here, for everything here, you have already moved them to 3, right? So everything here is 3, right? So if everything here is 3 and you have to make this 4, you have to pay 1 unit of cost extra for each of these elements, right? Similarly, everything here, you have made this 3 already, right? So you might have paid some CDS cost already. Now for everything here, you have to move this to 4, right? So to move this to 4, you have already paid some cost to move this to 3, right? So you have to subtract that cost, because this cost you have paid to move this to 3, but you have to move only till 4. So basically you can skip one step for each of those elements, because everything here is greater than 3. So for each of those elements, you can subtract one one unit of cost, because you have to move now up to 4. Okay, so what exactly we are getting at? So basically, for everything up till 3, we will add the cost of each of these values once. Okay, so let's say the cost of each of these value is p. So you will add p in 20 because 20 was the cost to move everything to 3. Now because you know that you have to move everything here to 4 because these all elements are already less than 3. Okay, so you made this to 3, but now you have to make this to 4, so you have to pay one extra cost for each of these. So this p is the extra cost. Now for each of these elements, they are greater than 3, right? And you have paid extra cost, like you have paid some cost to move this to 3. Now you have you can subtract 1 unit of cost for each of these elements, and let's say that is q. So the total cost now to move everything to 4 is 20 plus p minus q. So don't worry if you don't understand it. We will look at a concrete example and that will make things much more clear. Okay. So just to reiterate, what we are doing is we have said that we know the cost of moving everything to 3. That is 20. Now we want to calculate the cost of moving everything to 4 from this 20. That might save us some pre-computation or some computations, right? So what we have said is, okay, let's identify, let's, we have moved everything to 3. Now we have to move everything to 4. So let's say every element which we have, which are less than 3, we have moved them to 3, right? And now we have to move everything to 4. So each of these elements will be contributing, will be incremented once. So for each of these elements, you will be paying some, like you will be paying 1 unit of cost. Now same argument goes for the element which is greater than 3. For elements which are greater than 3, for each of these elements, you will be paying one less unit of cost. Okay, uh, one less unit of cost. So that's where you will subtract the single unit cost for each of these elements from the total value. Okay, so you have moved everything here to 4 and you have moved everything here to 4, so everything is now 4 and you get the value. So now if you remember, this is what, like, just to this is what we have done in written format. So what we have done is we have we know what is. So first of all, because we have to find everything less than 3 or everything greater than 3, we can sort this array. Now the cost is also associated with each of these value, so we have to sort this pair itself. Okay, so now let's make this pair. So this is the sorted pair. Okay, this is a sorted value, and each for each of these value we know the cost. Okay, now let's say you know the cost for everything up till 3, and now you want to find the cost for everything up till 4. So what you will first find, well, you will find the index where everything is up till 3. So you will find this. Now once you find this, what you want, you know that you have moved everything here to 3 already, right? And you also know that for everything here you have moved it to 3 already, and for all these operations you have paid 20 unit of cost. Now you have to move everything to 4. So for each of these elements, they are now 3. So for each of these elements, you will be paying 1 unit of cost, exactly 1 unit of cost to move them to 4. And for each of these elements, you have already paid enough cost to move it to 3, but now you have to move only to 4. So for this 5, you have paid 1 into 2, 2 unit of cost to move to 3, right? But to move to 4, you have to pay only 1 unit of cost. So basically, you will subtract 1 from here. Okay, so you will add this much and you will subtract 1 from 20, and that's what the value for 4 would be. Okay, so you'll find move of cost, which is everything from 0 to index till x. You'll find move down cost, that is sum of everything till from starting from index x plus 1 up to n. And then what is the actual difference between this cost, like the moving from x to x plus 1, the actual difference is move of cost minus move down cost. Okay, And let's see what if this is applicable in this example. So we know the value for moving everything to 3 is 20. Now we have to move everything here to 4. So what is the cost? 2 plus 14 plus 2, which is 18. So you will, like, p is 18 here. Okay. And now for q is 1. So what is the cost? The total cost is 20 plus 18, which is 38, minus 1, 37. So let's see if 37 is the cost for moving everything to 4. So for moving 1 to 4, you have to pay 3 unit of cost. So basically 3 into 2, 6 unit of cost. 2 to 4, you will have to increment it twice. So again 28 unit of cost. From 3 to 4, you have to increment this once. So you will be paying 2 unit of cost. And you will be paying 1 unit of cost to move 5 to 4, because you have to decrement it once. So what is the cost? 28 plus 6, 34, 36, and 37. That's the value. Okay, so hope you get this. So what we are trying to find now, we have said that we already calculated some x, and we know how to move from x to x plus 1 with this set of operations. And if you have noticed, all this set of operations can be done in log n time very easily. So index till l, till x is just a binary search. You can do it in log n time, right? And next thing is move of cost. It is sum of some prefix, right? Sum of some prefix, you can find it using prefix sum in order one time, right? Now again, move down cost is also sum of some prefix only, so you can actually find it using prefix sum itself in order one time, right? And finally, the difference is just a mathematical operation, which is again order one. So from moving from x to x plus 1 is order log n operation. So what we can do, we can find out everything at, like, we can find out the cost of moving everything to 1, and then for each of these value, like from everything from 1 2 3 4 5 6, each of these we will be paying log n cost. So final complexity is 10 to the power 6 into log n. Okay, so this is the final complexity of our solution. Now let's look at an example, concrete example, and that will make things a bit more concrete. So this was the initial array. What we have done, we have sorted this with in terms of value, and because each of this value is associated with a cost, we have to sort the entire pair. So 2 comma 14 moves together. Okay. Now, if you remember, we have to find out move up and move down cost. That will be a prefix sum. So prefix, we have calculated the prefix sums of cost, and prefix sums of cost is 2, 16, 19, 20. Now, for moving everything to 1, you can actually calculate in order and time. There is no issue in that. Now, I have already calculated it. For moving everything to 1, the value is 24. Now let's see what is the value for moving everything to 2. So if you move everything to 2, what was the, like, if you remember, we have to find out everything which is less than equals to x and everything which is greater than equals to x. Now for everything which is less than equals to x, we will be adding the cost. So we will be adding the cost up till here, 2. Okay, and then we will be adding the cost for everything up till here, for adding the cost for everything after that. So subtracting the cost for everything after that, because everything here needs to be moved to 2. Okay, so what is the value? The value is uh, if you notice, like, the sum of all this, sorry, sum of all this would be simply 20 minus 2, right? So 20 minus 2. Now if you see this, this will be equals to 2 plus 2 4 minus 20 and then plus 4, right? Which is equals to, okay, there is some confusion here. So basically, to this is 24 initially, right? Because initially cost of 24. So 24 plus 2, 26, and then minus 20 plus 2. So that becomes to 8. So cost of moving everything to x equals to 2, x equals to 2 is 8. Okay. Now similarly, for let's say we have to find out the cost of moving anything to x equals to 3. Okay, this is the last thing. So we know we have to find out everything up till 2. Okay, so we have to sum this part up, and this will be our p, right? And you have to sum this part up, this will be our q, and we can just do the mathematical calculation here. So what is the sum of this? It will be simply 16, right? So the cost was 8 initially, we will add 16, and then we will subtract q is this part, which is 20 minus 16, which is 4. Okay, so 18 plus 6, 24, 24 minus 4, which is 20. So cost of moving everything to 3 is 20. Okay, so hope you get what we are doing. Now the complexity, if you remember, was 10 to the power 6 into log n, right? So this may or may not pass. If like if you do lead code, you might have aware that they have unnecessary tight complexity sometimes. So now if you notice here, index x is strictly increasing value. So we are starting from 1 and going till 10 to the power 6, right? So index till x will also be a strictly increasing number. So you can actually do a two pointer technique, or one, like you can just maintain a pointer, and that will actually serve the purpose. You don't need to do binary search for this value. That pointer would actually tell you the value. For example, if let's say if at x equals to 2 you are at this particular position, so for x equals to 2, you x equals to 3, you can simply increment the pointer up till you get x equals to 3. So the pointer will be here. Similarly, for x equals to 4, you will keep on incrementing until you get x equals to 4. So this will be here. And for x equals to 5, you will keep on incrementing until you get x equals to 5. So this pointer will be here. So hope you get how to find this pointer. So this log n will also be removed, and final complexity would be order of 10 to the power 6. So let's quickly look at the code that will make things clear. As discussed, we have sorted the array, and we have sorted it based on both value and cost. Sorry, value, and because cost is associated with the value, we have to sort them together. Now we have find out the prefix of cost. This is just simply prefix finding prefix of cost. So now we have started with x equals to 1. So for x equals to 1, we have find a cost till x, which is cost till x equals to 1, by just iterating over all the elements, right? Now we have we know what is the cost of x equals to 1. So we have started with x equals to 1, and we will go until 10 to the power 6, right? So current value, we know what is the value of x equals to 1, so we just take the minimum from result. And then we in like this was the value for index till x. So index till x is initially 0, and we keep on incrementing it until we get uh, x, like this values which is less than equals to x. Now finally we find out the move of cost. Once we get index till x, we'll find out the move of cost using prefix sum, and find out the move down cost again using prefix sum. Now finally the cost till x would change to, we will add p and subtract q. Okay, so this is the entire solution. Hope it makes sense. If you have any doubts in the problem, please post them in the comment section below. I'll be happy to answer. If you like the video, give it a thumbs up, and do subscribe to the channel if you haven't already. As per YouTube stats, almost 90% of the viewers are not yet subscribed or like the video. So I would strongly recommend to do that. That would help. That will encourage me to make more such video in future. So with that, I will see you in the next one. Thank you.